If you are in the business of developing AI that should be running at the edge on this kind of device, like this NVIDIA NGX Orin, for doing vision AI, things like that, you will not want to miss this new episode of the IoT Show, where Payman and Vladimir will explain and demo a new open source project. And that's today on the IoT Show. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today I have a couple of engineers to discuss an open source project that's very interesting. So let's start with the introduction, not to spoil it. Vladimir, let's start with you. Who are you?
Yeah, thank you, Olivier. Thanks for having us. My name is Vladimir Postel, and I'm a product manager in the Azure Edge and Platform team, where I'm focusing on helping developers modernize their AI application in the edge, across the edge and the cloud.
Okay. And what about you, Payman? Who are you? What are you doing in life?
So my name is Payman. I'm also a product manager as part of Azure Edge and Platform. And for the past couple of months, I've been working on experiences for developers and operators as it intersects with Edge AI and AI more generally.
Great. You both are here to announce, talk about, and demo a new open source project. So what is it?
Yeah, so this open source project is called CAN. And I will kind of explain a little bit of a joke with the name. And it's short for Cube AI Application Nucleus for Edge. And we came up with this name because we thought CAN, which actually in Mandarin means to see, is a good fit for the project. And I think as we get into it, you will see why that is.
Yeah. We said Edge AI already, right?
Yes.
So that's the first hint there. So why Edge AI is important? So this project will help developers streamline their Edge AI application and deployment and operations, and we'll see how. But why is that important? We know Edge AI is important, but reminder about exactly what kind of scenarios and why should people care?
Yeah, of course. So Edge AI is a subfield of AI that allows you to bring your AI models and business logic to the edge and run locally. And it's really important in scenarios where you need to make decisions in real time with very low latency. And it can help businesses to optimize their operation at the edge. And there are many use cases that you can see here in the slide. And for example, in retail, you can optimize your inventory management and stock your shelves in real time, on demand. Or you can improve your queue management. In manufacturing, you can think about scenarios about defect detection. Or in automotive, you can realize use cases that can help you in autonomous driving, where decisions have to happen really fast at the edge in real time.
Great. And in the past, when we started connecting devices, right, long time ago, it was about having the intelligence being in the cloud. And more we're saying that what we need is to have that intelligence come to the edge, right? Hence Edge AI, to be able to have these models run as close as possible to the data, because you don't have time to do a round robin, like to the cloud and back to, or taking action or whatnot, right? So that's another element that's pretty important here.
Exactly.
But we're talking about, running models on devices that are not rack of servers or a data center. And so developers here have a new role of not just developing devices that sense or developing apps for a cloud with infinite resources, infinite memory and compute, virtually, right? But developers are facing new challenges. Payman, can you tell us about what the Edge AI technology presents in terms of challenges for developers?
Absolutely. So as Vlad, my colleague, mentioned, there are a lot of business opportunities for this, but it gets really hard for developers and operators to actually implement something that's scalable, can actually be used for many of these use cases. The way I kind of think about it is I divide it up into three sections. When you want to build such a scalable solution, you have to think about how do you develop the application that's going to run on these devices, how are you going to deploy it, and then how are you going to operate it. And when you're doing all of these work, you have to kind of consider what it takes to build it in a scalable fashion and not just something that you build for POCs. So considering these three elements, starting from what it takes to develop, I think it's quite complex. Developers have to think about many things when building these applications. What sort of devices is going to be running on? what sort of runtime I'm going to decide to choose, what sort of models, and how am I going to make sure it's optimized to run on these devices. When you go through the deployment process, you have to consider what's a scalable way to deploy these applications across many devices of different sort. Could be size, some of them could be large and could process many frames, some of them could be quite small. So you have to consider, how do I build a system that can actually develop to all of these set of devices and not just a subset? And you need to make sure to be able to actually take advantage of some of the AI acceleration these devices provide. And in terms of operating, you also need to be able to make sure operate these applications on these devices. As we know in IoT, you have scenarios where these devices may go offline. So you have to make sure as you're operating it, you're considering those scenarios where devices may go offline, and you still need to be able to kind of understand, hey, my application, I may not know about the status of my application, but it's probably running properly in those devices. And when the devices come online, they need to be able to kind of adapt with the scenario and continuously run as expected. So considering all of this, there are a lot of complexities. Developers need to build these applications the right way. Operators need to be able to kind of set up a system that can work in correct scenarios. And because of this, we are kind of coming up with this project which can answer some of these problems really easily.
Yeah, and we're using the word developer very loosely here, right? Because we're talking about developers who are building embedded devices, the ones who are creating AI algorithms and models to be run on devices, the one that deploy application. DevOps actually, as we'll see, has a role to play here. So multiple hats, sometimes different people, but we call everyone developers. That's what we do here.
They're all developers.
So how are we helping all these developers, all these people with CAN? What is CAN about?
Yeah, so I think the piece about CAN is that we are providing you an open source project that has a couple of elements. It has an element, overall in the most broad sense, we give you one environment, developer environment, where you can go build applications, and we can actually see a demo a little bit later on how this is done. So you have an integrated environment, you can develop applications there, you can then deploy them and operate them all in a single environment. And this environment has many interfaces, APIs, portal, and we'll have a demo later on to show how this is all done. So this means that you only need to kind of focus on your application logic, what it really matters for your company, and not really the piping of how everything functions. And since this is an open source project, and we've built it on top of Kubernetes, and we can also get in there, it's something that is kind of more forward-looking in a sense that your investment that you may have on Kubernetes or you may have in the future are all going to be part of this process. And as an open source project, there may be community around it, and hopefully we get some support. And you have some good foundation to kind of build your use case on top of.
Great. Well, I think we need to see it now, right? So we're going to jump into a demo.
Yeah, absolutely. So let me show you quickly how it looks like in practice. So this is the CAN portal, and this is where everything connects and comes together. And this is, you can host this environment on your own Kubernetes cluster, on-premise, on AKS, or on any Kubernetes cluster on any cloud provider. To bring this up, you have to run an installer that we have in our GitHub repository. It's really easy. We have step-by-step guide, and you can complete it in less than 5 minutes. And once this portal is up, you can create your Edge AI application, deploy them, and operate them, everything in one place. And there are 5 concepts here. On the left side, you can see these main concepts that we have. One is the compute devices. Those are the Leaf edge devices where the inferences, your machine learning models, and the business logic going to happen locally. Then we have the cameras. We are talking here about Vision AI, but this solution is very flexible and can be expanded beyond vision. So we connect the cameras where we take the feed from the physical world, take all this unstructured data and process it and create insights. The third one is machine learning models. And the fourth concept is the AI skill. The AI skill is helping you connect your machine learning models and business logic to create your own custom video pipeline. And then the deployment, this is the last step, where you connect everything together. You take the compute device, you take your camera, you take the skill, package them, and deploy them to the edge device. So let me show you a real business use case for how you can use it to create an Edge AI application for vehicle occupancy, where you can do different things such as curbside pickup or optimize the management of the parking lot. So the first step is the compute devices. So you can add any device. You can add an IoT edge device, or you can add a Kubernetes-based device. And basically, you can connect your Kubernetes cluster, like I mentioned. And I have connected 5 different edge devices here already. AKS Edge Essentials, this is your Windows IoT devices. AKS Hybrid, which you can connect your Azure Stack Edge CI devices. This is the third one is Kubernetes cluster. This is a vanilla Kubernetes cluster that you can connect. And I also have 2 IoT edge devices here. One is eFlow Windows IoT, and another one from NVIDIA, the Jetson Orin, that runs the new Jetpack 5 acceleration. The next step is the cameras. So now let's see the cameras, how easy it is. So I have one camera that's already connected here, but let's add one more. So I hit Add Camera. Then I give it a name. I put an RTSP URL for my camera, gives the username and password. Then I specify what devices have access to this camera so I can process the feed. In this case, I choose the Windows IoT device on AKS. And I specify also the location. You can imagine that if I have many cameras, I would want to organize them by location in my solution. Then I hit Create. And boom, my camera is connected now. I can click View and see the camera feed. The next step is the models. So in the models, we have 2 options here. One is create your custom model. And this is an integration that we do with Azure Custom Vision, where you can bring just 15 images, tag them within the experience without leaving the portal, and create your own model. And then we have the models with some out-of-the-box pre-built models as an example that you can use out of the box. So I created a custom model here for low stock detection, for instance, but you can add any other model that you wish for your use case. And I have a couple of models here that are pre-built for people and vehicle understanding. So the next step that we are going to do is move to the AI skill. So let's go and create a skill. So I hit Create Skill, I give it a name, I specify the acceleration and the desired frame rate. So I optimize the hardware for the inferences. And then we have this beautiful interface where you can drag and drop and connect the models and your business logic. So in this case, we are creating a scenario for vehicle occupancy. So I'm dragging and dropping a model here. Then I'm selecting an object detection and pedestrian and vehicle detection in this case. Then I'll add a filter. Some models have hundreds of classes, so we want to filter them just for the use cases that you need. Then I specify the confidence. It also depends on the use case that you have, the confidence that you want to run with. And then I'll add another model here to classify the colors of the vehicles. And then we have this, and to do that, we have this gRPC custom processing. And this is my favorite node. It provides so much flexibility because you can bring your own business logic or your own machine learning models to this video pipeline. Then I'll drag and drop the filter here to filter the results. And the last step is the export, where I can export the insights from this pipeline. And I have a couple of options here. So in this use case, I'll drag the export video snippets. And this is used where I can record a short video snippet for 10 or 20 seconds when something interesting happens. For example, a new car arrives to the parking lot. Or if you bring a model to detect theft, for example, you definitely want to capture a short video snippet to record it. Then I'll drag another node to export it to an HTTP endpoint. And this, you can imagine an integration with a different system. So if you're implementing a parking lot and you want to charge automatically users, customers for how long they spent in the parking lot, you can do that with this node. And there are a couple of other nodes here. For example, you can send your insights to IoT Hub, or you can send them to an IoT Edge module locally without streaming data to the cloud.
Or you can send it to an HTTP endpoint. So you can actually target ADT or some storage or whatever, right?
Exactly, yeah. And the last step is the deployment. So this is where everything comes together. So I already have one deployment here. I'll add another one. I'll give it a name. I'll choose the device where I want to deploy it, and then the camera that I want to process the feed. And I can connect more than one camera here. Then I configure my camera, so I'll take my camera and add a skill to it. So in this case, I'll choose the vehicle detection skill that we just created, and I can apply a couple of skills to the same feed. So I can process the feed with in different ways. And then I create my deployment. It can take a minute, and boom, it's ready to go. Now, let's go into the deployment. So you can see on the left the frame rate. So we capture what's the performance of the deployment, what's the acceleration. So if something goes wrong, you can see it and monitor it. And then I'll go to the camera, and I can see it live here. I can see the insights that are coming from the pipeline. And I can see the video recording that I captured with the inferences and the bounding box from the detected vehicles and the colors.
Nice. Nice, pretty straightforward actually. Everything drag and drop, right? So
yeah, it's very, very
anyone
easy.
can do that. Anyone can do that.
Yeah, and you can do it for less than 10 minutes. I have another deployment here that I want to show you. I did it before on an Oren device.
Okay.
And this is for stock detection. And this is basically to optimize your inventory management. So you can see the camera here, and this is in a retail store. And then you can detect when the stock is low and automatically in real time fulfill the shelves to make sure all the products are available.
And that's super interesting, like that scenario, because the data is in that store, right? The inference and the management of that data happens in that store, doesn't go out. So for people who are freaking out because, hey, I'm going to go in the store and my face is going to be recognized and so on. Well, data for privacy reason is staying on that device. It's locked down there, and it's only the insights that come out, which is like number of people that have been counted, or empty shelf, and then you trigger a workflow on the back end. So that's really fantastic, really great UI, and like all of these super UI type of things that you say that, but I want to reinforce that. This is a portal that comes in the open source project. You will deploy yourself on your own instance on your own cluster, right? So you don't need Azure as a subscription, right? You don't need to pay anything to anyone there. You need to have a cluster. You can start on your laptop to try it out also as well, right? Yeah. And so if you want to connect to IoT Edge or whatever, you will need Azure, but you don't have to have it to play around with CAN for now. Right?
Yeah, absolutely. And even if you do it in Azure, you don't need to have hardware. You can do everything in the virtualized environment. So you really can get started in a few minutes.
No excuses. So now let's look at what's under the hoods, right? How is it built? It's open source, but before people jump into that, Payman, can you walk us through what is under the hoods of this very nice demo that Vladimir just showed us?
Yeah, absolutely. So I think it also helps us to kind of understand better how it functions, and kind of is good for our next demo, which I'll present in a little bit. So the way to think about it is there are two layers that you need to consider. One layer is the layer which my colleague just showed, the portal and the API that runs underneath the portal and all the dev tools that we have. And this layer is the layer where you interact with it. So this is the layer that most developers and operators will interact with to manage the resources, create applications, deploy and operate them. And this layer runs on top of a Kubernetes cluster, could be AKS, could be a Kubernetes cluster that you have yourself, and this is your command center. You could kind of think about it. After you have this command center, you may have many edge devices that are running in different locations. You could have retail, where in a retail scenario, you could have these devices, one device per store, or you can have multiple devices per store. And all of these devices are going to be running your AI skills or AI applications. So you can actually control all of them through the portal and the dev tools and the APIs they provide to you. But the actual application ends up running on these devices. And as you kind of demoed a little bit earlier, we support IoT Edge and Kubernetes. And it's pretty extensible to kind of support more and more devices. And it is quite important to be able to do this, considering that for many of these use cases, you may have existing systems and devices that could be large or small, or you may want to kind of modernize and have more and more modern devices, and maybe you want to adopt Kubernetes. So both of them are going to be supported, and everything would function. And each of these devices could be processing many video cameras, one or many video cameras. And again, you don't interact with these devices. They're kind of like headless devices. Your interaction is through the portal, DevTools, and APIs.
Okay.
Now, talking about APIs, I think it's quite important for us to, we showed the demo on the portal. I think it was great. And I think many of the users will start there, maybe stay there long term. But it's good to kind of see what you could do on the API layer. Because that's also a place where you can build your own portal if you would like to, or maybe integrate it with some other systems that you want to interact with. So for this, I actually have a demo as well. So going to my system, I think one of the things I want to highlight is that this is built on top of Kubernetes natively, meaning we built these abstractions that my colleague just mentioned, Vladimir mentioned, as Kubernetes objects, custom objects. And we have our own controllers and operators then act on these and do the job needed, which means you could continue using existing Kubernetes tools to interact with them, using kubectl, for example. So we just showed earlier that we had two AI skills. So if I do kubectl here and do get skills, I can actually see the two skills that were created running here. And this is one of the things that's very powerful. All the concepts you saw earlier, you could interact with them using kubectl if you would like to set their status and everything. Now the cool thing is, well, kubectl is great, but I'm not going to go kubectl every single object and interact with them this way or create them. How can I do this at scale? How can I make sure my operators and developers kind of working together, the DevOps scenario? And so my developers continue building these, and the integration kind of happens automatically. And I don't have to continuously worry about, is this device working or not? Is this deployed or not? So this is where GitOps comes in. And for GitOps, if you have your cluster, if your instance of CAN is running on an AKS cluster, there's already a GitOps integration there. You could set that up and allows you to interact with GitOps through that. If you have another Kubernetes cluster, you can connect it to Arc, which is a extension of kind of allows a lot of these Azure resources to be extended to your own infrastructure. If you Arc enable your clusters, your Kubernetes clusters, you also have the option to enable GitOps through that, and then interact with all your clusters, even if they're not in Azure, through GitOps, and deploy these applications directly from your Git repository. So considering that, what I have done is I have a Git repository that I made for this demo. And currently this repository has nothing in it. It's an empty repository with no information in it. But I also have a code spaces environment set up, where in this code spaces scenario, I actually am connected to this branch of my repository. And as a developer, I'm defining these applications we showed earlier as descriptive files. So I describe my, for example, AI skill, I describe my deployment through YAML. This is the way you interact with Kubernetes. And after I'm done with this, I would demo, I can actually just push these YAML files to my GitHub repository. And as this GitHub repository is connected, GitOps is enabled in this cluster, the configuration will be automatically configured on that cluster, and I don't need to do anything. All I need to do is make sure my desired state is configured correctly on my GitHub repository, and as a developer, I can do that. And I don't need to worry about how it's going to function with Kubernetes and how it's going to develop there. So with this, I have two skills here. I have a skill definition. I quickly will show it. as you saw earlier, we had this drag and drop interface. It was really interesting, and you can really easily build applications there. All of that actually is built into the YAML. So all it happening in the portal, we're building this YAML for you, but you could directly interact with the YAML definition and define your application directly through that and describe it. So same description is happening here. We're defining a skill here that detects vehicles and send a message to IoT Hub. Okay. And we have another skill that records to Azure Storage. So we have another scenario where a vehicle is detected. We store a 10-second snippet of that to Azure Storage. And the concept of deployment in the portal, we have a concept of instance. So that's just a different terminology we use for the same concept. So I have two instances here. One that is deploying this, my IoT application, this skill that actually sends a message to IoT Hub, to an IoT Edge device. And then there's another one that deploys my video recording scenario to a Kubernetes cluster. So I've built these YAML files, and I haven't yet pushed them to my cluster. So all I need to do is, let me just bring this up a little bit to give me more size. All I need to do is to kind of build, I'm just going to kind of, let me actually zoom in maybe a little bit here. Yeah, I don't know if you guys can see, but I think it's probably fine. I can also, so I'm just going to commit the changes. So as a developer, I'm going to just create a commit, new skills and deployments, and then I'm just going to push it. And what happens here, if I, yeah, I think I made a mistake with the git commit. So this, I'm just going to copy this.
Live demos.
Live demos, it happens, right? So that issue with Git.
I think a demo is more impressive when you fix it.
Yeah,
I know. It makes it a lot more. So if I just make a change to Git here, all right. And if I do Git push.
Now it works.
Yeah, exactly. Now it's pushed to my actual Git repository, and I can kind of refresh this, and I see the YAML files here.
Yep.
Now, as a developer, my job is done here. Right? I've done this work. My operator has already configured this on Azure. So I already have the GitOps configured, and it's already happening. And all I need to do is kind of wait for this to succeed. So this continuously monitors the Git repository. As new changes happen, it applies them to the cluster. So if I go back to my kubectl, it may take a little bit of a time, but
yes, it takes time for downloading the containers, right? So that the new pods are running on these clusters, and then for them to run.
So it takes a little bit of a time. It depends on how you configure your GitOps configuration. You could make it shorter intervals in terms of checking. So yeah, so now that we have done this, it takes a minute or two for the configuration to actually apply. So let me actually go and see if everything has been applied. So I'm just going to run kubectl skill like before, and you could see that I've added two more skills, the ones that I've configured earlier in my Git repository. I didn't do anything. All I did, I just pushed it to my Git repository that was connected, and I could actually do the same thing with my instance. So these are the deployments, and I will see two deployments, and you see even the status of those deployments that are configured correctly. And if I go to my VS Code, if I stop monitoring the built-in endpoint and actually go here.
So one of your pipelines was about, one of the skills was about sending data to IoT Hub, right?
Yes. Yeah, so I think this also takes a little bit of time, because what happens is these modules get deployed to those devices. So it takes time for those modules to actually run. And after the modules run, we have to also initiate the pipeline. And the video pipeline is the actual application that runs through the frames, runs the models on them, and then at the end of the day, send the messages when a vehicle is detected. So this could also take a little bit of a time. So while this is happening, I think we can come back to this. I can actually show you more of an overview, a little more deep dive, so what actually happened here, and kind of summarizes things really well.
Yes, because you started with a high-level architecture diagram, but it's interesting to see. We heard, things about GitHubs, things about, the pods that you've been playing around with. I think, and that's super important, because AI at the edge and the IoT story is evolving towards including more of these IT tools. And we're just using them like that. But at the end of the day, I like this diagram to showcase exactly how they're used in that context of an edge compute solution here.
Exactly. So as you could see in this diagram, it's a little bit busy, but I think I'm going to go from right to left, and I think it kind of makes it much easier to understand. There are three ways you can interact with this project or the project running in your own environment on your cluster. We saw the portal earlier, and that's one way you could interact with it. Earlier also showed the integration with GitOps, Arc GitOps, and AKS, which happens through the Flux operator. So that's one way you could interact with it. And then the other way is using kubectl. So if you want to use kubectl and interact with it, you could do it that way as well. And underneath, all of them are communicating and doing the work on our implementation of a controller, an operator that runs on the cluster, that describes all of these objects, describes all the tasks that needs to be done. So at the end of the day, all these interactions are happening to that layer. So that layer is kind of like the most extensible. And then this layer is the layer that kind of uses Kubernetes and all the concepts to orchestrate all these workloads being deployed to different devices. This includes your existing cluster that you're running the portal on. So if you would like to, for example, even run your AI models directly on the cluster you're using, if your cluster is running maybe at the edge, you could do that. And the way it works is that we take your definition of, let's say, AI skill and your deployment, and then we end up creating skill pods in a Kubernetes instance. You see that you have the skills pods running that are actually processing the video coming from these cameras. And in an example that earlier we showed, there was an HTTP endpoint, for example, that you could use to send these results. And here we're showing like a business logic pod that you could, for example, build. If you want to do more processing, some other work, those results could actually directly be sent there, or you could directly send it to IoT Hub if you would like to, or digital twins. You could directly interact and send these results to digital twins and then do your further processing from there. And beyond Kubernetes, we also support IoT Edge, so you could run the same similar process on an IoT Edge device if you would like to. And then we have integration with Acri from a perspective that you may use Acri for discovery of these devices through UNVIF. And you could do that, and all this project does is make sure these devices that you actually discovered are usable. You can actually get benefit from them, run processes on them, and get the right insights, and be able to also manage all these applications at scale. So this is kind of an overview. There are a lot of stuff that we talked today. But I think the most important thing is how can you get started? And
we did cover a lot of ground here. So you guys put together a blog post. We're going to bring up the link here. But Vladimir, last word here. What is the call to action? So go visit, go read the blog post. But I think you want to show us a little bit of the GitHub repo and a few of the information that are in there, right?
Yeah. So this is our GitHub repository, and it's public. And it has here a get started. So go to the get started. There is very easy step-by-step guidelines that we published for you. So you can start easily and really create an Edge AI application in under 10 minutes. And you don't need to have, again, just to emphasize, you don't need to have any hardware to get started. You can run it on your PC or virtualized in the cloud and host it in your own environment. So give it a try.
Awesome. And as a matter of fact, you don't need hardware because the magic of Kubernetes and these edge technologies is that the same software will run on these different types of hardware, independently of the software itself. You don't have to readapt the software. Anyways, this is material for more IoT Show episodes. Thanks for staying with us. I hope you liked the demos. I looked you were going to love CAN and use it. And we hope to see you again on the Edge soon. See you. Thanks, you guys.
Thank you.